Hey, welcome to hack number 52. Can you believe it? I made it a whole year. Woohoo! Well, we got something special for hack number 52 this week. We are messing around with lasers. Yep, that's right, green lasers. Don't shine these on people's eyeballs. Okay? Be careful with lasers. But we're going to play around with some lasers today. We're going to make an oscilloscope, so to speak. It's an oscillograph. And it's going to be a lot of fun and a really cool hack with a really neat outcome. And you can make one of these if you follow along and you've got the right parts. So, let's get started!
So to get the little linear actuator I need, I'm going to pull it out of this old laptop hard drive. And this is, I think, a T6 Torx maybe? Because I have a T8 and the T8 doesn't fit it. But have no fear. I have a drill press. Easy peasy. There's the inside of the hard drive. There's the linear actuator that moves the head back and forth. This is the part I want to salvage out of here. And it looks as though there are two rivets and a screw holding it in. I really wish I had that T6. I gotta go buy some smaller Torx. So back to the drill press. Oops, that really wasn't the thing to do, because in drilling those two out I kind of disconnected this whole assembly from the frame, and the frame is what this is connected to. So this part is connected to the frame, this part is connected to the frame, and I just drilled out these two rivets that hold this in. Now this is loose, so that's no good. It's okay. We have a backup. Let's see. This one has Torx that I actually have. So, this is the last one. This is the 1 year hack right here. And everybody's like, what are you going to do? I hope you keep doing them. And I'm having a lot of fun doing them. I don't really make much money doing them. There's a little bit of ad revenue, of course, from Google. You see those ads pop up all the time down there. And some people click through, some don't. The ones that click through, hey, thanks, I get a little bit of your click through. So, I'll keep on doing some videos, but they're going to be a little different format, I think, and maybe not necessarily a different hack every week, but I'll be keeping you updated on things that I'm doing, projects that are ongoing, and you can get like an update on what's happening with that project each week. We'll do something like that. I'm just basically taking every single screw out of here that I can find that looks like it's holding this cover on. We're getting close. There we go. It always blows my mind how shiny the surface of that stuff is. Say hi to yourself, YouTubers. There we go. That's what I'm after, right there. That linear actuator that moves the head. So let's see how it's installed in this one. If it'll come out in one piece or if I have to actually cut this frame. Because I need to mount a laser to the end of that, and that laser needs to be shining out freely without anything in the way while this moves back and forth from an input from anything that makes a waveform, basically. Okay, more surgery. So, hack week will keep on going. It'll just change a little. So stay tuned. I'm going to take about a month-long break. Do some other things like go camping, take a hike, go walk the dogs. You know, just be nice to not have the pressure of doing a hack every week. It's been lots of fun. I'm really surprised I was able to pull off all but a couple. And I kind of made up for it, at least with some content to watch. Okay, what we got here now? Yeah, this looks like it's like the other one. This is all part of the frame. So I've really got to do some hacking, literally with a hacksaw, and cut away the frame so that this can stay mounted in it and I can have free access to this end. That means I've got to pull out all of this media That'll be fun. Here's a little trick with some Torx. When they're tiny like this, you don't have a Torx bit, you can use a flat blade, because a Torx is basically 3 triangle shapes overlapping. So 2 of the points are across from each other. And if you've got just the right width screwdriver and you wedge it in there good, you might get lucky and get it to turn. Woo! Well, we got all that stuff out of the way. Get the motor out. There it is. Alright, everything's out of the way, the discs are gone, the motor's gone, and we can get at this linear actuator and see what's going on and what makes it tick. There's a winding on here, not unlike a voice coil on a speaker, that I want to access, and it looks as though 2 little wires kind of run under the ribbon cable there, and they end up over here, and then those 2 wires connect to a strip right here, a copper strip on this flexible PCB, and they run along the bottom here parallel. So it's the first 2 traces on this, on the bottom, that I need to find over here somewhere and get the pinouts, and potentially through to the other side, and I can find the pinouts here and tap into them there for my input. I've soldered some leads down in there. Can I get close enough to see what I had to do? Whoa, that's crazy. It was kind of tricky soldering those 2 on, but they're on and they lead to the coil here in the actuator for the head. So let's hook it up to 3 volts in this polarity and see what happens. Oop, okay, goes that way, and let's reverse the polarity. Goes back the other way. Try it one more time the other way. Doesn't move until I push it. Aha! There's a little magnet, a little parking magnet for when the head goes home to hold it there. It looks like it's right here. It's a little... Let's see what happens if I mess with that. It's in a little rubber thingy, it looks like, and there it is. Out it comes. That's it. No more parking magnet. Now it can swing freely each way, so we can hook up an audio signal to this and we should see it vibrate a little. Let's try that next. Okay, we got the audio output from the laptop running through a little 386 amplifier, and then it runs over here to our hard drive. Let's see just what this thing does when we turn some music on. It's kind of a techno song, so it'll have some good bass transitions. Get some pretty intense little vibrations going on there. Surprising how much sound it puts out. If I put it on a box, it would probably make even more sound. Okay, so we know that works. Now it's time to cut all of this framework away so that I can have a laser pointer LED mounted right here, blippity blip, and then we can shoot that onto the mirror. That's the next thing to build. There we go. I did 2 cuts on it. I cut it off this way and also cut this corner out of the way so that the full sweep of the laser will be unobstructed. Alrighty, this little laser has to get mounted on the end of the arm here now so that it can shine out there and wiggle back and forth and create a pattern on whatever it shines on. The easiest way to do that, I figure, is a little bit of hot glue. The laser is connected. The wire runs the same way that the ribbon cable does. That lets it flex. And what you're seeing and hearing right now is a 40 hertz wave, sine wave. And that's coming from my laptop from a program called True RTA that I have used before. It's a freebie. Go check it out. It's called True RTA. Really cool. It's a signal generator oscilloscope for your computer. You know what the sound card can handle. But anyway, I digress. So here's this, and we need to see that now in the dark, shown on a piece of paper. So let's get things set up to do that real quick. And there it is. That's the 40 hertz wave. You're just seeing it making a trace up and down, showing amplitude to positive and negative. It's a sine wave. So if we now could show time, we would see the sine wave just like on an oscilloscope. How can we do that? Well, we can take that laser and shine it onto a spinning mirror. And then if we change the speed of the spinning mirror till we get it in sync, because of our persistence of vision, just like the phosphor remaining glowing on an oscilloscope, CRT, we will see a waveform. Hopefully. So let's get that rotating mirror built now. I found something here that might do the trick. I can vary the speed to change the speed of the spinning mirror. Now I just need to get the mirror stuck onto there somehow. I removed that gear that was on top of there so that I could put a mirror in here like this. And it can rotate. Now I've got to see if I can grind away a little bit of this mirror to accommodate where the shaft comes through here. That might get a little tricky. If not, I can potentially shorten this a little bit because it has a collar underneath that holds it on. See that little thing? That's like a little clip. God, hacking's fun. Well, that took a bit of work, cutting a slot in the gear and all that, and then getting the mirror to sit down on there just right. And they put a little triangle 90-degree gauge here, and it looks good. It's curing up, it's epoxied in place, ready to spin around in circles. I sure wish I had an optical bench. That would be a lot of fun to work with, but my bench will just have to work for now. I've finally got this set up. It took a while to set up. I've got the laser mounted here, pointing at the spinning mirror down there, and then the spinning mirror will reflect onto this viewer I made. It's just a piece of paper stuck in a cardboard box, so it gives you a little bit of a dark field around here, and the light will shine right across here. JFET's coming up to check things out. It's all good, JFET? Everything look good? All check out alright? We good to go? Alright, he's purring. That's a good sign. So I'm going to flick this switch and the mirror will come on. The mirror is spinning and the laser is on. And let's fire up the sound generator here. Got an 85 hertz sine wave going on right now. Let's turn out some lights and take a look at this waveform. Whoops. So there you go, you can see it. The video of course makes it a little more blinky, I guess, but that's basically how it's looking to me right now too. It's kind of a pulse, but you can definitely see a waveform there. There's a peak and a trough, and if we knew the exact voltage coming out of that right now, we could actually make a graticule on here, or a grid, and we could tell what the peak voltage in the positive range and negative range was, and then we could even figure out peak to peak what kind of a time base we are looking at here. So you could divide this up into seconds, microseconds. There's JFET again. JFET's blocking the laser. Get out of the way there, buddy. So now what I want to do is ramp this whole thing up a little bit by installing a green laser. The red one's not too bright, and then I want to make a nice little display here, and then I want to install a potentiometer on that motor and see if we can play around with syncing different frequencies so that they show up, because the speed of that motor is what determines whether or not we see a waveform here. Let me jump up a couple notches in frequency here, and you'll see I'm at 107 Hertz now, and the waveform's still there, but it seems to be, to me, marching across the screen a little bit differently, a little harder to see. Anyway, let's play around with that potentiometer now and hacking a green laser on there. Avoid exposure. Laser light is emitted from this aperture. Good advice. Don't point these things into your eyes, or into your pet's eyes, or anywhere else that it could be in someone's eyes. Not a good idea at all with any kind of laser. This is the green laser pointer I'm going to take apart and get the laser out of that to put in this device. It's pretty bright. Green lasers are really bright, and they fluoresce at night, so that'll be interesting to see how that works out. Well, we changed the setup quite a bit here. I suddenly realized, hey, I don't need to take this thing apart and take the laser out. I just need to aim it at a piece of mirror mounted to the armature of the old hard drive here, and then that will reflect down here to the spinning mirror, and when it moves up and down it will reflect the light onto our screen. Basically, this would be the CRT, I guess, in a real oscilloscope. But as the mirror spins, it lets the waveform move across the viewing screen there, so to speak. So, and that's over here on this side, the Hack-A-Week laser oscilloscope, a little graticule there. So that's the whole setup, and it took quite some time to get everything lined up really nice. Everything has to be on axis, like you see, all nice and lined right up perfectly. And the mirror and the laser, the way it bounces off, by the way, a little thing of physics, light rays that come into a mirror, or anything for that matter that's a flat plane, they bounce off at the angle of incidence. So if it's coming in at 30 degrees, it will bounce off at 30 degrees. So just a little bit of crazy math there about what photons like to do. Alright, enough of this blah blah. Let's turn this thing on and see what kind of cool stuff it'll do. Okay, we have the lights turned off. We are ready to go. Let's fire this thing up. The mirror is spinning around. It's actually making a waveform along the walls. Pretty wild. There's the armature moving around at 120 Hertz. Now let's go take a look at the waveform that's getting generated on our screen. And here is the output from the Hack-A-Week laser oscillograph. I call it an oscillograph because it's an oscillation and we are drawing it, hence the word graph, draw. So there it is on its own little graticule on a high-tech 8.5 by 11 20-pound Bond screen, and Albert Einstein is in there observing the waveform. And anyway, that's a sine wave. It's 120 Hertz, and it's from my laptop on the signal generator. I can change the waveforms. Let's try a different one. Let's try a sawtooth and see just how much difference there is. Hey, look at that. It's actually showing us a sawtooth. That's pretty cool. Let's see, what do we have? Also a triangle. Let's try a triangle wave. It's not too much different from the sine wave, but that doesn't surprise me too much. The resolution of this device is not really that high, but it's pretty cool that I can get a waveform to even appear on this thing. I just happen to be in sync at 120 Hertz, and I had to use my other camera to get the frame rate right. The one I usually use for Hack-A-Week didn't work. It was showing only partial bits of the waveform.
Let's look at pink noise. Just about what you would expect. A waveform that's just all over the place, because pink noise is all frequencies, attenuated 3 dB per octave, I believe. How about some music? Let's see what music looks like on here. Let's see, we'll go to the Free Music Archive and play a song called Oscillator by Mink Lungs. Okay. You can play now. It's downloading. Here we go. Look at that, it's music. It's a musical waveform. Well, that's pretty cool. So anyway, that's about it for hack number 52. Can't believe it's been a whole year since I started doing this. It was a lot of fun. I learned a lot along the way, made some friends here and there online along the way, and I look forward to keep going in this new year, but just not in the same way. I'll be doing some long-term projects and showing you the videos of those as I go along. So be sure to check in. I'm going to do a couple of videos in the coming weeks of a recap of this year's entire collection of videos. A little bit of a snippet of the best of each one. And I will be doing a bloopers reel soon, which should be a lot of fun. And then after about a month goes by and I get to have a little downtime, I'll be back at it. So be sure to check back then. And until then, you know the line, right? Keep on hacking.